Hi guys, I hope you can see me now, and I'm trying to record a video and also explain about decision trees and some algorithms which I used for performing bike estimation and rental demand estimation. Actually, I've used different kinds of algorithms to estimate the bike rental per day in my last video. I wanted to explain how these algorithms work and why I have used, because I've received many DMs to explain those algorithms. I'll be starting with a decision tree, as it is one of the most easiest to understand algorithm. So in decision tree, usually you can see the term trees. So in this particular algorithm, we have parent node, and you have also different levels for each tree. Normally in trees, they can be like this, or it can be like a Christmas tree. So usually the decision tree is like level by level. It's sometimes it can be ordered decision tree, or you might have heard about binary trees or 0 1 trees, and these are different kinds of algorithms which help in studying behavior modeling, and also in estimating any relational behaviors. And also it is used in sales and marketing for actually drawing different hierarchical schemas. So usually I'll draw a rough estimation of how the decision tree usually looks like, and how my professor used to explain me. So usually you have grandparent node, grandparent node, then grandparent one, and grandparent two, then again parent one, parent two, parent one, parent two, child one, child two, child one, child two, child one, child two, child one, child two. So like this, you can see I have drawn a tree, and similar to a family tree where you have senior grandparents, then again they have their grandparents, and those grandparents are also have parents, and those parents have children. So if you see from the bottom to up, it is similar to a decision tree. So these nodes which are at the most bottom, these are called as the leaf nodes, and these particular nodes, these represent the attributes, or usually the column names in the data set. Usually in a data set, in our bike estimation data set, we have several attributes like count rental, season, feels like, temperature, humidity, pressure. So all these kind of different attributes, they contribute to represent the node. So what is the senior grandparent? The senior grandparent is called as the root node, or the decision node. So in a bike estimation rental problem, you can say the root node would be the rental count. The rental count is basically the target attribute. So all the other attributes, the parent and the parent one, here they are actually fall under the labels, like the feature labels, and all the other labels which are not the target label are called as the other attributes which form the tree. So every time you see there are different branches for the tree. So to split a particular node into branches, we actually use a different kind of statistical formula which keeps running behind in the backend. So every time you see the value on the right side will always be greater. So you can say as a greater than b, and here it can be something like b is less than c. So on the left side you have attributes which are lesser, and on the right side we have attributes which are greater. Okay, and you can also see that all the attributes which are over here in this particular space are on the lesser end, and all the attributes which are here are on the greater end in a decision tree. And one other thing, where the splitting condition, it takes place at every particular node, and that is how a decision tree is actually built. And this was about what is a decision tree and how it actually looks like. So you can actually plot this decision tree also. I have plotted my decision tree in the previous graph using the scikit-learn plot tree library. And you can also represent the decision tree in the form of any visual graph, where like this kind of tree, or you can also imagine a Christmas tree like I have drawn here, though it doesn't look like a Christmas tree. And it is actually one kind of a Christmas tree which I have drawn. Okay, so for example, if I have numbers like 9, 4, 3 and 2, and while building the decision tree, then I'm giving an example of how decision tree usually works. So I'll take the first value 9. So 4 is less than 9, so it will go on this end. Then again, if I want to put 3, then 3 can actually, 9 is 9 is less than 3, then again 4 is also less than 3, so it is again put here. Then again 2, when 2 is also less than 3, like this. But there are some kind of traversal in the decision tree where I have actually put it in linear order, but you can actually traverse the decision tree using in-order traversal, pre-order traversal, or post-order traversal. Like this, different kinds of traversal methods are used inside the decision tree. So that was all about the decision trees. But what kind of statistical calculations are used, I'll explain you now. So friends, in machine learning, when we use the decision tree algorithm, then there are three different kinds of algorithm which can be used in decision tree. And the first one is the ID3 algorithm, and the second one is the C4.5 algorithm, and the third one is basically the Cart algorithm. So Cart is actually very famous, and it is used for both classification and regression, but these two algorithms are used mostly for classification algorithms. So when you think about classification, suppose if I want to predict when I have a when I'm going to have a baby, then will the baby be a male child or a female child? So we know that this is directly classification. But suppose if I have a basket of fruits, and if there's a probability that I might actually want to go to fruit shopping, and I might pick various kinds of fruits, ranging from pineapples, grapes, apples, kiwi, or pomegranate. Like this, can pick different kinds of fruits. And also, suppose if my target would be that I have to pick a fruit, and there are various kind of fruits, and there are continuous values, then there is a chance that I might actually use regression algorithm or a classification algorithm here. Since here you can see the values are limited, but mostly in supermarket the values might be unlimited and might be continuous values. So I might pick even a set of fruits, but here we have only 4 values, so you can directly use a classification algorithm. But if I want to have something like a set of flowers, which are basically a big basket of flowers, so the probability has to be detected that what is the probability that I might choose a basket of grapes, and how many grape samples. Like I want to choose 198 grapes for some puja or something, so the probability might be 0.75. And here I also want to choose some kiwis, like some 108 kiwis, and the probability of this one would be something like 0.27. So you can see my target ratio and the output would be 0.75 or 0.27. Okay, and I will actually choose a regression algorithm here because I'll be actually wanting my machine learning algorithm to be predicting a continuous value, or actually outputting probability value. And when you actually have values like something like 3, 7.5, 8, 9.2, then again 7.6, all these values are decimals and they are continuous one after the other. And if I want my output to be something like 1.2 or some kind of floating value, so if I want this as my output, then I mostly will be choosing a regression algorithm, because you can simply say regression works exceptionally well for continuous value, and when you have a lot of features which are numeric or categorical features which are encoded. So that is how this one works. And in ID3 algorithm, like I told, it is a classification algorithm, and in this particular ID3 algorithm I'll mostly be using entropy and information gain. And in C4.5 algorithm I will be using information gain and gain proportions. In Cart algorithm, usually it's a like classification and regression trees. So the actually here it is uses the Gini indexing. Gini indexing is actually called as the ratio indexing, where misclassified ratios are taken after a particular decision tree is built, and it is actually built like this again, using different kinds of statistical multiplicative functions. And after that, like it actually picks a number of samples, and it tells you if what is misclassified samples ratio. Like suppose if I have loads of samples which are belonging to estimate A, but the actual estimate is somewhat between B and C. So the Gini indexing there would be somewhere between the total number of samples that were A, B, C, D. No, sorry, A. Like, see, the actual value, the estimated value was A, and the actual value lies between B and D. So the total number of samples here are A, B, C, D. So say 4, and the Gini indexing, the actual and the estimated difference would be somewhat between 3. So it would be 0.75 Gini indexing. That means there is error of 0.30. So we have 30% error value. So the Gini indexing, how much ever it is lower, the better is the error or the model loss, or how much prediction is there. So I had to actually predict like A was predicted, but the actual values were B and D. So I'll actually also share with you different statistical formulas, like how entropy and information gain and gene indexing is done. And I'll also give you a small problem that I will only be defining. So you can actually see an example of how decision tree problems are solved by clicking the link below, and the decision tree will be mathematically statistically solved. And also I will be explaining one problem, because you'll be able to understand how entropy, what is entropy. Like if I just say you it's impurity, then you might not be able to understand. So I will use some numbers to explain this decision tree algorithm.